Assalamu alaikum everyone. Today our lesson is Types of Chemical Reactions, Chapter 8, Lesson 2, Types of Chemical Reactions. The objectives for the lesson as mentioned below. We will define and give general equations for synthesis, decomposition, single displacement and double displacement reaction. Second, we will classify reaction as synthesis, decomposition, single displacement, double displacement, and combustion reaction. We will list the 3 kinds of synthesis reaction and 6 kinds of decomposition reactions. This is in part 1. In part 2, we're going to talk about double displacement and single displacement reactions. We will list 4 kinds of single displacement reactions and 3 kinds of double displacement reaction. We will predict, inshallah, the products of simple reactions given the reactant. The general forms of the different types of chemical reactions as mentioned here. Synthesis reaction, when there is an element reacts with another element producing one compound, or one compound reacts with another compound producing a new compound. So 2 reactants, 1 product is a synthesis reaction. While decomposition reaction, which is opposite to synthesis reaction, it's 1 compound, okay, decomposes or breaks down into 2 new compounds, okay, or 2 new elements. One reactant, 2 products. While here in synthesis reaction, 2 reactants, 1 product. In single displacement reaction, there is an element reacts with a compound, and this element tries to take the place of one of these elements in the compound. The single displacement reaction depends on activity series or in the reactivity series. If the element is highly reactive element, it can replace another element in the compound, forming a new compound and producing new element. Double displacement reaction, reaction of 2 compounds, both of them dissolving in water or one of them dissolving in water, producing 2 new compounds. Combustion reaction, it's a reaction between a compound and oxygen, or an element with oxygen, mainly it's the hydrogen, producing a new compound plus heat, okay? In part 1, as I mentioned, we will start with synthesis reaction. We will go through definition of synthesis reaction in details and types of synthesis reactions. In synthesis reaction, as we said, which is also known as a combustion reaction, 2 or more substances, when I'm saying substances, I'm talking about elements or compounds, combine to form a new compound, okay? 1 compound. This type of reaction is represented by the following general equation: A plus X give AX. A and X can be elements or compounds. AX is a compound. The order of elements, now I'll talk about the chemical formula, how to write the chemical formula for the compound. The order of elements in the chemical formula is as per their order in the periodic table. What do I mean? I mean, for example, if there is a reaction between sodium and chlorine, you know that sodium comes before chlorine if you go from left to right in the periodic table. So you write an ACl. This is the order of elements, not Cl and A. This is the first point. Also, carbon and oxygen, CO2, okay? Not O2C. This is the first point, how to write the order of elements. And to write the chemical formula also, you need the oxidation number or the charge for each element. You know that sodium is a metal from group 1, so the charge of this metal is +1 and Cl is -1. So you will switch the charge and simplify. So you will get an ACl 1 to 1. The subscript of Na is 1, the subscript of Cl is 1. Where C and O, carbon and oxygen, carbon is 4, we will say positive 4. It's not exactly positive 4 because it's non-metal, but we are talking about positive polarity and negative polarity. Positive 4, oxygen, negative 2, switch the charge and simplify. So you will get C2O4, then you can simplify it into CO2. This lesson is already done before in chapter 6 and 7. Type. Now we will go through 3 types of synthesis reaction. As we mentioned here, type 1, reactions of elements with oxygen or sulfur. Type 1A, reaction of, I'm saying element, yani either metal or non-metal. Reaction of metal with oxygen or sulfur, example, lithium reacts with oxygen. Why do I write O2, not O only? As you know, oxygen is a diatomic element that exists in the form of O2, okay? O2. Lithium plus oxygen give lithium oxide. You know that I will read this formula here. Li is positive 1 because it's from group 1 plus oxygen, it's negative 2. So you have to switch the charge. Gives Li 2O. Now instead of 2, it's 1 because of the charge of lithium. Okay? And don't forget to balance as you have learned before in the previous lesson. Now, another example, reaction of metal. You know that sodium is a metal. Reacts with sulfur. Sulfur exists as S8 in nature. Okay? Sodium positive 1, sulfur negative 2, so Na2S, and you have to balance the chemical equation. Type 1b, reaction of nonmetal with oxygen or sulfur. Nonmetals like carbon reacts with oxygen, producing carbon dioxide. Okay? Type 2, reaction of metals with halogens. All of us know what are the halogens. Halogens located at group 17. Halogens, chlorine, chlorine, bromine, and iodine. It's in nature they are in the form of diatomic elements. Okay. When a metal, an active metal like potassium, reacts with fluorine, okay, producing salt. And how we will read this one? It is potassium fluoride. Potassium fluoride. You know that you have to end the chemical name with IDE. Yeah? The first element, which is metal, the name of the ion is the same name of its neutral atom, where the name of the negative ion must end with IDE. Okay? So potassium reacts with fluorine, give potassium fluoride, okay? And don't forget to balance the chemical equation. Another example, for example, calcium plus iodine, or start, okay, calcium plus, for example, Cl2. Yes, okay. The product is, you know that calcium is positive 2. Why it's positive 2? Because it's from group 2 and Cl group 17, so it's negative 1. So you have to switch the charge without using the sign. So Ca1, invisible 1, you can write 1 or you can, it's up to you if you don't like to write the 1. And Cl, now this 2, it's from the charge of calcium. It's not the subscript of that indicates it's diatomic element, okay? and the equation is already balanced. Okay, so you have a metal, an element plus another element producing one compound, so it is synthesis. It's a synthesis reaction, synthesis reaction. Okay. Now, this third type of synthesis reactions is the reaction with oxides. When I'm saying oxides, there is oxygen. Oxides, either metal oxide or non-metal oxides. So the first type, oxides of active metals, when I'm saying active metals in group 1, group 2 mainly, react with water to produce metal hydroxide. So take this as a rule. Wherever there is a metal oxide, active metal oxide like sodium from group 1, the metal oxide of sodium oxide, that sodium, I will do it like this here, sodium reacts with oxygen, producing Na2O. Why it's Na2O? Because sodium is positive 1, oxygen negative 2, just switch the charge. Okay, so you will get Na2O. The metal oxide of sodium, or the chemical formula of sodium oxide is Na2O reacts with liquid water, okay, producing metal hydroxide. Sorry. Okay, metal hydroxide. So be careful in this one. So again, metal oxide with water producing metal hydroxide, which is a base. Okay. Where the opposite to it, non-metal oxide, okay, non-metal oxide like SO2, when it reacts with water, the product is an acid. So again, metal oxide with water producing a base, non-metal oxide with water producing an acid. Which type of acids? As you know, there are two types of acids, binary acids and oxyacids. So you will get oxy acid, okay? Oxy acid. Like sulfur, sulfur dioxide reacts with water, you will get sulfurous acid, okay? Another type of, or another form of synthesis reaction is the reaction between active metal oxides plus non-metal oxides. The product is a salt, okay? As you can see here, calcium oxide plus sulfur dioxide, the product is calcium sulfite, okay? Calcium sulfite, which is a salt. This is about synthesis reaction. So again, I want to say something about synthesis reaction with oxides. When there is two compounds, one of them is water and the another is metal oxide or non-metal oxide, so it's synthesis reaction, not double displacement. Be careful, because we said two compounds react with each other. One of them is aqueous or dissolving in water, in aqueous solution. So it's double displacement, not synthesis reaction, okay? Sometimes it makes confuse for some students. Now, decomposition reaction, which is opposite to synthesis reaction. In the composition reaction, single compound, as we said, one reactant undergoes a reaction that produces two or more similar substances or compounds. Decomposition reactions are the opposite of synthesis reactions. They are represented by the following general equation. AX is a compound producing A plus X, either two compounds or two elements. Type. Now, the first form of decomposition reaction is decomposition of binary compound. Binary means two. Binary means two. Binary means two. Example, the electrolysis of water. Water decomposes into hydrogen gas and oxygen gas by using an electricity. If you have a sample of water and you pass an electric current through this sample, you will get hydrogen gas and oxygen gas. The second example, which is a mercury oxide using heat, you will get mercury and oxygen gas. Be careful when you write the chemical formula of oxygen gas. As you can see, it's O2 and hydrogen gas is H2. You have to use the subscript 2 to indicate that this is diatomic element. And decomposition reaction happened by using either electricity, or when you see this triangle, it means heat. Okay, so decomposition reaction needs either electricity or heat to occur. Second form of decomposition reaction is decomposition of metal carbonate. Carbonate, which means CO3. As you know, the polyatomic ion chemical formula for carbonate is CO3, as you know. Okay. When metal carbonate, which is mainly it's active metal carbonate decomposes by using heat, it will decompose into metal oxide, okay, and carbon dioxide. So when a metal carbonate is heated, it breaks down to produce a metal oxide and carbon dioxide gas, okay, like this example. So, type 3 decomposition of metal hydroxide. In the previous type of chemical reaction, we were talking about synthesis reaction, how to produce metal hydroxide. Metal hydroxide can be produced by different ways. One of them is the reaction between metal oxide and water. Metal oxide and water, active metal oxide plus water producing metal hydroxide. So if you have a metal hydroxide, how you can break down this compound into new compounds? By using heat, it will break down into metal oxide. Calcium is the metal and oxygen. Metal oxide plus water, okay? So the composition of metal hydroxide into two compounds. One of them is water and another one is metal oxide. Okay. This is form 3 of decomposition reaction. Form 4, decomposition of metal chlorates. All of us know what we mean by chlorate. ClO3 -1. So if you have a compound like KClO3 or, for example, NaClO3, you know that Na is +1, so the total charge, the total subscript is 1, and ClO3 is 1, so 1 to 1. I will not use the brackets. By using heat and MnO2, it's a catalyst. Catalyst, as you know, is used to speed up the reaction, okay? The product always is the metal chloride, which is the metal here is Na and the chloride is Cl, plus oxygen. Oxygen, you cannot write O, you have to write O2. And oxygen at room temperature in gas state, and NaCl or table salt, okay? And this one, KCl, is salt. You know that there are many types of salts. Table salt, which is NaCl, is an example of that salts, okay? So decomposition of metal chlorates into metal chloride and oxygen. Into metal chloride and oxygen. As mentioned here, when a metal chloride is heated, it decomposes to produce a metal chloride and oxygen gas, okay? By using catalyst to speed up a reaction. Decomposition of acids. We learned before how to produce acids. Acids can be producing by the reaction between water and non-metal oxide. Was one example of them was CO2. Okay. So if you have a reaction between non-metal oxide and water, you will get acid, oxyacids. So how you can decompose the oxyacids? So you can decompose the oxyacids onto water and non-metal oxide. Here we have carbonic acid. Using heat, it will decompose into carbon dioxide gas and liquid water. Okay. Another one, which is sulfuric acid. Dissolving in water. This means by using heat, we will get SO3 gas and H2O liquid. Okay. This was the part one of our lesson, types of chemical reaction. Now I will record another video about single displacement and double displacement reactions, okay, in another video.